Hey, welcome to this edition of Show Me the Code. We're going to be talking survivability. Everybody, welcome to this edition of Show Me the Code. My name is Joseph Cervantes, and I'm here with Mr. Wayne D. Moore, and I'm so glad that he's here. Before I let him introduce himself, I wanted to fill you in on a story that should make this pretty relevant. So I was working on a construction site as an operations manager. I was there just to kind of follow up with the contractors to see how things were going, because we were waiting for final inspection from the third-party tester and then to bring in the fire department to do all their final inspections. So the job had been installed. All the trades were basically off. They were just working on the exterior to get it to look good because they were going to open, and there's planned revenue because it was a hotel. I'm not going to tell you where it was. I'm not going to tell you who the jurisdiction was, but here's what happened. I brought the jurisdiction because we had some issues with some dampers in a vestibule of the stairwell. And he looked them over and he said, those dampers aren't necessary. We have the relief up at the top of the shaft, so you can take them out of the floors. We don't need to have that differential pressure in the vestibule. So he said, okay, fine. We'll just leave them as open vestibule, and the air can flow between the stairwell and there. And he continued around, and he's doing his spot checks and doing his inspection as they typically do. And he walked into the electrical room, and he looked behind the cabinet, and he's looking around at the room, and he goes and he checks the label on the door. And as soon as he did that, I knew exactly what he was doing, because it was a smoke control system, and there was partial re-evacuation or partial relocation and evacuation on the site. He was looking at ratings of the walls and to make sure that all the fire stop penetrations have been done. And he noticed that there was only a single layer of drywall on the inside of these electrical rooms. And he said, well, that's weird. Isn't this supposed to be a 2-hour raceway? And I thought, well, yeah. And so he digs into it a little bit further, and he found that they only single layered the walls, that they had installed the wrong frames and doors. And the contractor actually had to go in and bring in the trades to pull all of the finish off of the walls and to properly rate that enclosure to get it to a 2-hour for survivability purposes. And then they also had to do the same thing on the horizontals out on the floors. Now, if you can imagine, the site is already done, and we're coming in to fix all of this after the fact because it was missed that the construction needed to be done appropriately so that survivability metrics can be made. And I thought, what a better opportunity than to talk to one of the renowned experts in this discussion so that he can better explain to the public and to the membership or to anybody that's watching this video what it means to meet the intent of survivability. So Mr. Moore, thank you for joining the conversation. Please introduce yourself. Tell me a little bit about yourself and your industry history, and then I'll continue the questions from there.
Sure. Thanks, Joe. I have spent over 40 years in the industry, which just means I'm old, and started out in the Air Force as a electronics technician, got my training there, then left there, went into college and got a double E. I thought I was going to be an electrical engineer. And about 3/4 of the way through, I said, I don't want to sit at a table and draw circuits. So I'm going to do something else. But I got my degree anyway, and I went into sales engineering and wound up selling, at the end of the day, fire alarm systems. I sold other systems before fire alarm, like master antenna and intercom, but so I started selling fire alarm. My very first fire alarm system I sold, I didn't know anything about the code. I didn't even know 72 existed. And sold the system to a really good client of mine. He was an Italian guy named Mario, and I watched the system go in, and just looking at the system, I said to myself, this doesn't look right. So I went back to the office, and we had a guy that was, quote, an engineer, but he really wasn't an engineer. He was called that at Raytheon. When he left, he came to work for this company that I worked for, and he really wasn't an engineer. And so, yeah, there's something in Boston, some company in Boston that publishes codes called NFPA. I don't know what it's all about, but yeah, there is a requirement for fire alarm systems. So I called NFPA, bought a copy of the code. And back then it was only a few pages of 72 A, B, C, and D. It was what we call the alphabet series of the code. And so I read that overnight, and I went back the next day to the president. I said, hey, we're in trouble. The system I sold, and it's going to go in multiple buildings after the one that they're finishing now, is totally wrong. And he says, well, make it right. Thank God he did say that. So I went back out to the client. I told him what happened. I said, look, I really apologize, but we got to rip this system out. Luckily, it was in the rough-in stages, so it wasn't a huge issue for him. And we made sure it didn't slow him down as far as his building process. And we made it right. This was way before survivability came in the code. This was just having the right kind of wire, installing it properly, and all of this business. And I had no knowledge of audibility, of intelligibility, none of that was discussed back in the day.
Right.
But anyway, we made it right, and everything got approved by the fire department. So that was my first foray into fire alarm. Then I met a couple of people that I admired that had given some seminars, and they turned out that they were involved in the codes. And I said, so how do I get on a code committee? And then one guy said, well, you got to apply. And I did. And he says, you want to apply to NFPA 72E, that's the detection devices, because that's the one that does the most work in the business, and it's the one you really want to know about. So I said, okay. So I did that. And I jumped in with both feet and started learning more about how the code process worked. And it's like, you know, you don't want to watch sausage being made. It's a long, drawn out process. And actually the committee members do a lot of work. I mean, they spend a lot of time doing what they do. And so as we went forward, we started adding more research information in the code. Up until then, it was more of experience information was in the code because there hadn't been a lot of research performed.
Right.
But as we went forward and we started getting issues that we discovered, we'd ask somebody to sponsor research, and then it would come into the code. And so that's how we first learned about audibility and got that into the code.
Wow. So you've been working with life safety systems for enough time to where you were a pioneer, shall we say, of creating what NFPA 72 has become today, right? And I the reason why I feel like it's so important for everybody that's watching this understands we're talking to somebody who's been there and done that, right? When you talk about the proverbial been there, done that, Mr. Wayne D. Moore has been there and he's done that. And, and I promise you that when I tell you that I'm going to bring you the experts, this is the kind of individual that you need to hear from, because he's very passionate about this, and I think we both share that in synergy. And as he mentioned, he's part of the technical committees that look at these systems, right? So tell me a little bit about the technical committee or technical committees that you sit on, specifically with relevance to survivability.
So we were at a NFPA 72 code committee meeting. Actually, it was what's called a correlating committee meeting. And the correlating committee looks at all the different chapters of the code, make sure they all work together, and is kind of the overseer for the entire code. And it came to everybody's attention that we really needed to expand the emergency voice communication part of the code. And I was sitting next to the chairman of the correlating committee, who was a good friend. And he says, you know, we need to have a new chapter for emergency communication systems. And he looks at me and he says, you probably should chair that committee. So I started chapter 24 from scratch. And the first few meetings was not really a typical NFPA meeting. I called all kinds of people into this group, people from Bose, all the different communication companies, people from the military, because it all came around. What caused this to happen was mass notification from the military. They came to us and said, we want to interface mass notification with fire alarm. And we had no way to do that. And so we took a lot of their stuff and put it in the annex. And then when I got involved, we then started pulling some of that forward into the code. So the first few meetings were really rough and tumble. I mean, we had a lot of arguments, we had military, we had the Army and the Air Force against each other. The Marines were putting their 2 cents in. It was really interesting to watch the dynamics of this. And I had to, rule with an iron hand and try and get everybody to focus on the code.
Right.
So eventually we finally got to a draft, and we put that out for review, and we put together a legitimate 72 committee where people had to apply. And then we started developing the code.
Now, why was it important to do that? Why was it important to create a chapter specifically to evacuation or to alerting notification?
Well, there was nothing in the code really that covered the types of systems like mass notification and fire alarm. And of course, the big issue was always with fire alarm, it had to be listed for fire alarm use. And I don't want to get involved in a discussion about UL, but there are some things in the industry that slow the process down. So that you can look, and especially the people who are listening or watching this should know that in the security business, before there was any listing of panels, you could do almost anything with a security panel. I mean, they were really coming forth with some dynamic equipment.
Sure.
The fire alarm people weren't doing that because it cost so much to get it listed that they had to spend some time to sell the equipment to underwrite the cost of listing. And so they were very slow to change.
Right.
When the M&S requirements came in, everybody had to jump through some hoops quickly and say, all right, we need to learn more about this. And I had no sound and communications experience whatsoever. So I had to jump in and learn a lot. I was reading books at night and saying, wow, this is crazy. I mean, there was so much we were doing in 72 for emergency communication systems that was wrong that I was nervous that, we needed to get this out really quickly.
Wow. So when it comes to survivability and some of the pitfalls around survivability in construction, and really the example that I brought up is an extreme event that is seen, but it's not rare. So can you tell me a little bit about what the issue is around survivability? Let's talk about what is survivability first off. I think it's best to define that first.
So most people don't understand this, but survivability actually has been a requirement in the code since the 1970s. And it's a simple statement that says the system shall continue to operate when we have a relocation system above and beyond where the fire is. So if you have wire going through the fire floor, the system above the fire floor has to continue to work. And I'm paraphrasing here, I'm not quoting the code.
Sure, yeah.
But essentially it was staying that, and that was what survivability meant, was the system had to work during a fire. And that's because the fire department, when they arrived, the fire ground commander needed to communicate to the people that were still in the building that we had relocated, because they could be above the fire and not realize that the fire was going to come towards them and they would have to go even higher or whatever. And this is way before we had the majority of the buildings were sprinklered. So that it was a very dangerous situation in many cases. Granted, they were concrete buildings and there were fire ratings that helped contain the fire, but we didn't have a lot of sprinkler buildings. It's a different story today. All that being said, we needed those systems to work for a period of time. And so we went out and we had no way of doing this. There was no circuit integrity cable at the time. The only thing that we had was mineral insulated cable called MI cable. And I was in the installation field as part of my entrance into the fire alarm field. And MI cable is a real difficult cable to install. And it's affected by moisture. There's all kinds of things that can happen during the rough-in process that creates a hassle.
Sure.
Now, MI cable is used a lot in Europe. And MI cable is a 2R rated system, they call it. And it's a system because you have to use all of the components that are listed for the installation. So it's nothing like you just take a hammer and a nail and tack it to the wall. Okay, there's all kinds of stuff you have to do. So it's a real pain in the neck. Well, along comes a manufacturer that says, hey, I've got circuit integrity cable. we bought this company in Europe and they've done this, and it's a cable that looks like the cable that you use today in fire alarm. It's pliable. You can install it, you can strip it, you can put it on a control unit, no hassles whatsoever. And so I looked at this and I said, hey, this is something we should actually try and get into the code to allow the use of it. And so we did. And CI cable then became something that people were starting to use a lot. Now, it was expensive. If the cable we use for fire alarm, the typical fire alarm, fire protector signaling circuit cable, it costs 10 cents a foot. This stuff costs $1 a foot. But we were only requiring it for the riser cables because we wanted the loudspeaker circuits to work on the floors above the fire. And the wire was going through the area that may be on fire. Mm. This circuit integrity cable was designed to operate for 2 hours in a fire that reached the UL listed temperatures just before the melting point of copper, so 1800 degrees. So it was put in a UL test wall, if you will, and they would test it with that 1800 degree fire. They take the wall and pull it out of where the fire was, spray it with water as if it was being sprayed by the fire department from hoses, and then turn on, it would be connected to some electrical circuit, and turn on the system, and if it worked, it passed. And what happened is the covering on the cable was made of stuff that was ceramified. So it became all ceramic. So as long as it was in place, it was perfect. If it got jostled around, it would crack, and then of course you would have possible short circuits from the water. But in most cases, because it was behind walls, that wasn't going to happen. So this looked like the perfect thing we needed for the requirement for survivability. And so we immediately put it into the code. And then the other piece of this pie that you really need to understand, and it's so important, is that even though I may put it in the code today, say for the new 2022 code's coming out now, let's say it's in the 2022 code. Nobody's adopted that code yet. Nobody's even referenced that code, so therefore it's not required. So even if I'm an AHJ and I want to pull something from 2022, I can't do that.
Right.
Legally, okay? Yeah. The way this system works is the building code is what requires the fire alarm system. The building code references NFPA 72. Well, if it's a 2009 building code, it's certainly not going to reference anything beyond 2009 for fire alarm. So normally, in this case, the 2007 fire alarm code would be referenced in the 2009 building code. That's how it works.
Right.
So there was always this delay. That creates confusion in the marketplace. Mm. There's an awful lot of people that think NFPA 72 requires a fire alarm system, and it doesn't. It's really an installation code, installation application code.
Right. Yeah, I always educate people. I tell them that the International Building Code, or NFPA 1, if you serve in either of those jurisdictions, right, that those are what a building owner must do if they want to erect a structure. Okay, the building code tells you if you want to put up this type of a structure, here's the sorts of protections that you need. The standard NFPA 72 or 101 or what have you, those are the hows. If you're going to install a system that looks like this, this is how you should install it. It's an installation manual, right? And then there's supplementary review and qualification of those systems in the how manual, and that's UL and those standards that are built there. So if the code says it has to have a fire alarm system, and NFPA 72 tells the installers or the jurisdictions, here's how it should be installed, UL will test it to that criteria so that everything is correlated and they can trust that the environment or the location of the device is actually going to work in the environment that we're looking for it to. Sure. So well, thank you for clarifying that. Thank you. So you hit on a couple of things that I really want to dive into a little bit. One of them is, and we could start at the reference of the permit, right? The building permit, let's say it's a long-term design. It's been designed since the year 2006. There were funding issues or what have you. And the building permit was pulled in 2008. And here we are in 2020, and for some reason it's just barely getting started with construction. They fall under the existing permit of when the building was originally submitted for. So now all of the codes that apply to that building are referenced in that time period. Whereas the code today, as you've mentioned, has advanced so far, but it does a lot every 3 years during the cycle that we actually go through and review the code information. Right. So there's been huge advancements in communications. There was a fire, as a matter of fact, in Hawaii, where they had a building, the Marco Polo, and there were no sprinklers in that building. And people died in that building. And, you know, everybody's asking the questions, well, why didn't it have sprinklers in it? It's common sense. Well, it's common sense today, but it wasn't used when that code was developed in 2006, right? So, and that permit would have been pulled probably under the 96 edition of NFPA 72. So there's a lot of things that we have to take into account, and why it's so important for even the normal construction person to understand survivability. And you brought this up as well. We're relocating people in a building. So if there's a fire on the 8th floor, we've got to move people away from that location, right? So you're going to hear a different messaging below the building telling people, get out. You're going to be hearing different messaging for people on the floor saying, get out. And you're going to be hearing different messaging for the people upstairs to say, wait until we tell you to get out, right? And right. and that, the ability to do that in the building, to pick up a microphone in a control room down in the lobby and press that microphone and be able to talk to those people while a fire is actively going on the floor below 5 or 6 or whatever floors are above that. That's the importance of what we're talking about here. So we have to create an environment where the circuits that control these systems can still operate even in the middle of a fire that's raging at 1800 degrees.
Correct.
For 2 hours.
Yes.
Now that's huge. That's huge.
The issue a lot of people don't understand, but we don't care about the fire floor. In other words, I'll have arguments. People say, you know, smoke detector is not a 2-hour rated device. A speaker is not going to last for 2 hours in fire. Well, we don't care, because nobody's going to stay on the fire floor and wait for that to work. It's going to work initially. They're going to get out of the fire floor, and that's all we care about.
Right.
We are only concerned with the riser that's passing through. Correct. So the wiring on that floor is going to short out and burn, and when it does, it cannot trip the control panel. So the panel has to be designed to operate on what I call a survivable mode, so that it allow that circuit to blow the fuse, but it won't affect the rest of the building.
Wow.
So there's 2 things involved here. One is the wiring, and one is the design of the system to ensure that that fire floor wiring, when it shorts, isn't going to shut down the system either.
And it goes to serve, you know, the more vertical we go in buildings, the longer it takes to evacuate. And that's the reason why there's timelines between all of these things and why they have to survive for so long. Imagine being handicapped in a building. And I talk about this just because I try to educate on 72 when it comes to two-way communications. And it's about survivability of the cable. Whenever anybody asks me, how do I put together a two-way communication system? I ask them, what's the exterior rating of the building? And why is that so important? Because that tells you how you're going to construct, right? If you tell me your exterior is a 2-hour rated building, I know that the intent of that building owner is to build in survivability metrics so that the people that are there, in the event that they're handicapped, that they can be relocated to an area of refuge or take refuge in a space where they can still communicate with the fire department or a central station as the code demands for at least the period of survivability rating, which is 2 hours. So now we talk about a whole different installation, which is where I'm going to next with you. CI cable. If an installer or an AHJ is inspecting circuit integrity cable, and I understand this, so please humor me when I ask this question. Tell me, where do they find the information in NFPA 72 to reference how that cabling system is installed?
So Chapter 12 covers wiring and survivability. So it describes everything in Chapter 12. It doesn't require survivability. It just describes, here's what survivability is. So there's different levels of survivability.
Sure.
And predominantly what we're looking at when we're requiring survivability, which is what Chapter 24 does. 24 says you shall have survivability on an EVACS system, fire EVACS. So it says level 2. So you go to chapter 12 and it describes what level 2 is. And it's CI cable or a 2R rated system. So meaning you could use MI cable, or you could use a CI cable that is listed in raceway only. In other words, there's some that's listed in free air, some listed in raceway,
Sure.
and then there's MI,
Sure.
which is a combination. MI cable has got the aluminum sheathing around it.
Okay.
So those are the three options you have for level 2. Level 3 is described there, and you say, well, how do I make it level 3? Well, you don't make it anything. It's the building construction that helps you decide some of this. If the building is sprinklered, when you install a level 2 CI system, it becomes a level 3 because it's a sprinkler building.
Right.
So you look at the description, it's the same for both, except one is sprinkler, one isn't.
So level 0 would be a wood frame structure with no concrete in it. There's no fire rating to the exterior, no sprinkler systems whatsoever, potentially,
Well,
right?
Building could be sprinkled, doesn't matter.
Right.
If it's wood construction, 1 hour you rated, you're not going to put in a 2-hour system.
True. Yeah, because it'll be the system. The building's going to fall. The system's still going to be standing, right? I have some funny stories to tell you about that, where you'd be surprised at what they're doing. So level 1 means that we have sprinklers in the building, and we are mechanically protecting the cabling system for these functions, right? So fire alarm, emergency communication systems, bidirectional amplifier systems, those are all in a level 1 facility. It could be wood frame construction. Say we have a podium style building where you have concrete and then wood over it. How would you accomplish, and what sort of a wiring system would you use in that sort of an installation example? A wood podium building over, say, 7/1 or 7/2 or something like that.
So there's a couple things I want to say first.
Sure.
A lot of people in the industry think that putting wire in a raceway is making it survivable.
Right.
Actually, wire in raceway burns quicker and melts quicker than wiring in free air, because the raceway heats up in a certain location and just melts it right away. So never consider wiring a raceway by itself to be anything other than mechanically protected.
Right.
Okay, so in a level 1 system, you would just use your standard fire alarm wiring, and you would put it mechanically protected where the electrical code requires it. Otherwise, you could put it above the ceiling, drop ceiling, and properly installed, of course, or behind the wall.
Right.
You wouldn't have to worry about any kind of thing other than mechanical protection if it's required.
And now when you get into like a wood frame structure, you have concrete below, or concrete at grade and below grade, and then you go vertical and it's wood frame 1 hour. What do you do in that sort of scenario?
Well, you don't need 2-hour cable. And,
Right.
we finally put that in the code because people couldn't use some common sense. And they would say, well, I've got this wood frame building that's essentially a 6 or 7 story building, and we're going to put in voice communication. It's got to be survivable. And we said, well, wait a minute, the building isn't survivable for 2 hours. Even if it's sprinkled, I mean, it's going to help us, but
it's going to burn, and it's going to become more of a collapse hazard than anything. It's
exactly
okay.
Exactly.
All right. So level 2, we have mechanical protection. We have sprinklers. Oh, I'm sorry, that's level 3. But we have circuit integrity cable, which per the manufacturer's recommended installation instructions, they reference a UL standard. What is that standard?
UL 2196.
And do you know the basics of 2196 as far as some of the criteria that installing contractors should be aware of with that?
Yeah, there's a couple of key things today that's different than what it was when it initially started out. If it's listed as a CI cable in free air, you can install it without raceway. And the only time you would need raceway is if you need a mechanical protection. However, if it wasn't listed for raceway, you can't install it in raceway. I mean, you could physically do it, but it's not listed. So you have to be careful which wiring you're using and where you're going to use it. Now, if it's listed as a circuit integrity system, that means the wiring was installed in Raceway and they were tested together. And all the connections that were used were tested together, and the pipe, or the Raceway was made by XYZ company. You have to use that Raceway by XYZ company to meet the listing requirements. And some people say, well, that's really crazy. Well, it may be, but what UL says is, look, we don't know if it's going to work in ABC's Raceway because we didn't test it. That's all that means. It may still work, okay, but we don't know.
That's like somebody going and purchasing a Sharpie marker, and yeah, the black cap will fit on this red marker, but if I put it on there, I'm not guaranteeing that it's a sure fit, right? Because it wasn't tested to fit on this marker. Right. And it's important that people understand that, especially authorities having jurisdiction, that when they're reviewing these systems, you need to understand UL 2196 as it impacts the installation of this cable. There's another factor that I wanted to point out to you. There are some cables that are listed to be installed in electrical conduit, and how do they obtain 2-hour rating on that particular cable? Are you aware?
Sure. What happens is if they're installed in conduit or a Raceway, and we should discuss this for a second. Sure. Conduit in the code is rigid conduit. When you use that term, okay. Metal Raceway is EMT or intermediate Raceway, or one of the flexible Raceways, but it's not rigid conduit. A lot of people interchange the words conduit and Raceway, and you have to be careful. This caused some big problems in the industry because in order to install wiring in Raceway, it has a coating on the inside to allow the wiring to be pulled through the Raceway a little bit easier, okay? So the wiring for EMT and IMC the coating is a vegetable coating and doesn't interface at all with the wire, doesn't cause any problems. The wiring, the coating inside a rigid conduit is different, and it creates a interaction with the cable and causes the copper to turn to pellets. Obviously, it's not going to work, right?
Wow.
So when it gets to that temperature, it caused a great deal of problems in the industry, and we had to go back to UL and start looking at, all right, how do I install this? And so you won't find, I don't think there's anything that's yet listed for rigid conduit.
So it has to be installed in EMT Raceway.
That is listed with the wire.
Listed with the wiring. So there's specific manufacturers that have specific listing with specific parts that you have to use.
Correct.
And then in addition to that, it has to be mounted to a 2-hour surface.
Well, yeah, you want the surface to last long enough to hold the wire up, right?
So that means that if you're running from a fire control room to the other side of the building to get it vertical to go up to the next floors, because that's where your electrical raceway is, it has to be structurally mounted directly to the concrete from point A to point B. Otherwise, you are not meeting the requirements of UL because it was not tested, not being mounted on a 2-hour structure. Right?
So the other point you want to make is from that control panel to wherever you're going to go to the riser, that section has to be 2-hour rated. So it's either going to be in a 2-hour rated enclosure, or it's going to be in a raceway that is listed for 2-hour rated.
And let's talk about that, because that's where the conversation migrates to. How do I accomplish 2-hour rating from the fire control room to that location?
Well, I need to use CI cable, or the building has to be the protection source.
So I can put in 2 sheets of 5/8 drywall and box a soffit around my conduit raceway and potentially meet a 2-hour requirement with that?
That would potentially meet it, as long as the attachment of that drywall is to something that's going to withstand the fire as well.
Right. If it was concrete and I mounted the conduit on concrete, say at a parking garage, and then I wrapped that conduit raceway with two layers of 5/8 inch drywall on metal studs all the way down from point A to point Z, I'd wrap it into, that would be 2-hour equivalency.
That would meet the intent, yes.
Sure. Now, what about concrete? Can I put my pipe in concrete?
Yes.
And that would accomplish 2-hour rating as well.
Yes. For years, it was required that power wiring for fire pumps be installed in rigid conduit inside concrete.
Okay.
I'm not sure, I've been out of the installation part too long. I'm not sure you can install EMT in concrete. It would have to be rigid.
Okay.
But it wouldn't matter as far as the fire is concerned. It'd be well protected.
And I know, so here's another question. So what about once I get to that floor, I go from the fire control room to the electrical riser, and it's 2-hour rated. I go vertical in a 2-hour rated shaft, I'm assuming. And then when I go back horizontal on that floor, does that floor have to be 2-hour rated to each of those devices? Or is it once I separate from that riser, I can go into a 1-hour installation?
Yeah, anything on the floor does not have to be rated for 2 hours. It only has to be rated for whatever the floor is. And generally it's going to be 1 hour, okay? Especially if it's sprinkled. So your riser is going to have to be listed for 2-hour rating. Your cabinets that control all the connections have to be listed for 2 hours. If you're using wire nuts, you can get what's ceramic wire nuts now that are listed for 2-hour rating. But all of that riser equipment has to be the 2-hour rated.
So the terminal blocks, the EMT fit or the fittings for the wire, I believe they're like ceramic standoffs that have to be installed. NEMA 1 enclosures, I believe some of the manufacturers require, because there's vertical height restrictions because of the weight of the cable, that you can't go beyond 28 feet vertically with each run. So if you're going up a 50, 60-story building, you have to actually splice it onto a terminal block every 28 feet vertically per run. That's proper UL 2196 installation. So you brought up something now. What if I'm installing an area of refuge system, and I have two-way communication system, and I have a call station in an elevator lobby in the middle of the building, and I connect from that riser to that elevator lobby location? Wouldn't that wire pathway be required to be 2-hour in that corridor because it has to operate for the survivability metrics?
So at least for 2 cycles now, the answer is yes.
Got it.
For a while, we did not talk about the area refuge cables but again, 2 cycles ago, we said, hey, this is something we missed. And that's now a requirement that be 2-hour rated as well.
So whereas the signaling systems would only be required to be 1-hour survivable, if you're dealing with area of rescue assistance or area of refuge, that system that serves that has to be 2-hour survivable.
So now I'm going to throw a curve at you now.
Let's do it.
There's a new elevator system available today that we never were allowed to use elevators for evacuation.
Correct.
That's why we have areas of refuge.
Right.
And it used to really irritate the people in wheelchairs because they said, you made it easy for us to get into the building, but hard for us to get out. And so there was a lot of discussion, and I was part of that because I was working with that community to try and change that. And so now there's an elevator system that is programmable that we tell it where the fire is, and it goes from a standard mode to a fast mode, and goes up to certain floors above the fire and certain floors below, and picks up all the people and brings them down to the lobby.
Wow.
And of course, wiring that's connecting to all those controls has to be CI cable or listed.
That's the occupant evacuation elevator lobby system.
That's correct.
Right? Got it. Yeah. And so these are all found in the building code. There were some discrepancies, I believe, between the building code and NFPA. I can tell you that as a person who is personally sat on the ICC during the meetings, we did make the change for all those that do understand area of refuge, where the IBC is going to reference NFPA 72. We're still waiting on public comment to go through on that, but it was just a pointer that we needed from the building code to NFPA 72 as the how-to guide that's been missing, and it's caused a lot of discrepancy between what the industry feels like should be installed because it's code required, it's in the standard, and what a fire department says is actually enforceable because the standard isn't referenced in the code. So that's been fixed, potentially.
What's important for your listeners to understand is that no one in this business can install a fire alarm system with NFPA 72 in their hands alone.
Right.
Okay, there are 3 or 4 codes that you have to have knowledge of to do this work properly. Of course, one is the building code. The other is NFPA 72, electrical code, and then ANSI A17.1 is the elevator code. And so even though we may have information about how the elevator system should work, we've actually copied that from 17.1. But now that we've got this new occupant evacuation elevator system, that's all described in ANSI A17.1. That code by itself costs $400 to buy.
Yeah, and I can understand why. If $400 is a big investment for somebody that's working on those systems, maybe they shouldn't be working on those systems.
That's true. That's true. And today you're getting PDFs, and you may have a computer on site all the time anyway, and that's the right way to do it, is to have everything on a computer so you can reference very quickly.
Yeah. So really, my intention with this video in this conversation is to, we have to help in a few different ways, right? We have to help the AHJs understand how to inspect these systems for the wiring, because the building officials, the electrical inspectors that are walking these systems, they're the ones that are verifying these installation habits, right? So UL 2196 and Chapter 12 of NFPA 72 is going to be the guiding light on how the cabling systems for these buildings should be installed. There are probably others that I've missed, but I think that covers it when it comes to signaling systems and how they're being installed in the buildings, right?
So Article 760 is referenced by NFPA 72, and Article 760 is the electrical code.
Yes.
And that's a requirement you have to follow as well.
Yeah. So that's the National Electrical Code, Article 760 for low voltage wiring conductors.
Correct.
And why a contractor would want to know that, or why an engineer would want to know that, or why a developer would want to know that, is because obviously it impacts the cost of a construction site. It impacts the BIM modeling of your raceway, your conduit pathway from your fire alarm control room to your area of refuge, or to your electrical rooms, or to your IDF closets, or how you're going to get vertical in a building. And it could potentially, if missed, as I mentioned in my opening statement, impact the turnover date of a project, because an inspector that knows that the building was not installed properly will force you to go back and fix what was not done properly. And that could be very costly when you've got revenue projections, you've got opening dates that you need to make, and you've got contractors to coordinate, because you don't want to do this after all your finishes are already in. It's
so
very
issue, yeah, there's no question, you're right there. The issue, of course, is that not every fire inspector understands CI cable, and neither does every electrical inspector. So if an owner or a developer is assuming that the inspection team is going to cover this, they're wrong in many cases. And what can happen is the first inspector on the job comes in and okays the fire alarm system. Somebody else from the fire marshal's office comes in to look at what you said earlier, a different issue, happens to look at the fire alarm and say, whoa, wait a minute, we missed this. Well, shame on us, but you're still going to fix it. And that's the issue, is that the fire department or fire marshal's office can miss something and then come back and say, no, we missed it, but you got to fix it. And you got to do it.
So let's talk on that. let's hit on that for a second, Mr. Moore,
Okay.
because I think it's really critical for contractors to understand this one statement that I'll make here. You were given a contractor's license to operate in a state. And that contractor's license comes with the responsibility, whether you are an employee of the contractor or you are the contractor who has the license holder, the license holder himself, right? Or herself.
Exactly.
It states that you are going to follow the minimum requirements of all codes and standards that are enforced by that state that you're working in. And if we're talking the state of California, that means that you are going to meet the minimums of the current requirements if it's a new building or whatever is referenced for that building permit, that time period, okay? Now, if that's the case, and an inspector does not do a routine walk for NFPA 241, or they don't verify that your cabling is installed in a survivability metric as it should be, and something happens in that building, and somebody dies, God forbid, or something drastic happens in the building where there is a critical failure to that system, what are the potential implications on those contractors from a situation like that?
Well, you're talking to an area that I'm heavily involved in today because I do a lot of litigation work. And actually, I have 5 daughters, and one happens to be a judge now, a federal judge. And obviously, she was a lawyer before she was a judge. So I used to joke a lot about that, you know, God was getting back at me. But working with lawyers, I've learned a whole different attitude about how things work. The scene you just described, everything falls on the contractor. You can argue that the AHJ missed it, and everybody will say, yep, you're right. But we can't sue the AHJ unless he did it, you know, on purpose.
Negligent, right? Yes.
If he's grossly negligent, yes, you can sue. It's called, you can't sue the king, back from the ancient days. So you can't sue the city unless it's grossly negligent. That means we have to go to the person that should have known the right way to do it, and that's the contractor.
Right.
And it comes down to one word that you talked about earlier: responsibility. We, as a designer, I have a responsibility to know the codes so I can design the system properly, so that I can tell the contractor, here's how you should do it. And everybody should bid it on the same thing. And that's the right way to do it. But there's so many contractors that wind up going out to a job site, and you got 5 contractors bidding the job 5 different ways. And of course, low bid wins.
Yeah.
Well, low bid might win, but they also might lose when it comes time for responsibility when there's a fire. And Murphy says there'll be a fire.
And I think where this big misconception is that people think that the fire marshal has this, they have a very, very awesome responsibility. Okay. It is something that I can't even imagine. I talk to them all the time. It is an awesome responsibility. But the limelight is there because that's your city, so you're responsible for this, right? But where people fail to understand the line of delineation is that they're there to verify that what you've installed is according to the code, what they can see, right? And what obviously as humans, we're only trained so much, so we only have so much knowledge base. If you've seen the IBC, it's thick, right? The IFC, the IBC, NFPA 72, 101, A117.1. You talked about all of these different standards and codes. They're very thick. So we apply what's reasonable on that particular project. But it still does not alleviate the contractor's responsibility to meet the minimum intent of the code. So if you think you're going to cut corners and that you're going to get away with it, if something happens, you probably are going to wish that you would have spent the extra few dollars to research it and do it the right way.
So I'm not going to be facetious, but what's going to happen if there's a fire? Somebody's going to hire people like myself, and we know where to look, and we know what to look for. And the contractors don't stand a chance. If they've done something wrong, we're going to find it. And they can't expect it to burn up in the fire because we can reconstruct it as well. We know from research how things are supposed to work. So it really is an awesome responsibility. If you're going to install fire alarm systems, you really need to understand what you're doing. So important. And we talked today about survivability. That's just one piece of the system. Obviously an important piece, but it's just one piece. I mean, we talk about intelligibility, and we could do a whole course on that, a whole session on that.
I heard him just invite himself back for intelligibility, ladies and gentlemen.
I'd be happy to come back, but that's another issue that I harp on all the time is people don't get they don't have a feeling for communication at all. And I know I didn't. And now that I've learned the right way to do it, I'm trying to tell other people this is how you should be doing it.
Right. Well, we're thinking about the what ifs here, and if I'm talking to somebody that's in an emergency and this is what you hear, nothing's going to happen. You're not going to know what to do, right? And we need people to hear us clearly. So intelligibility is a very important thing, and something that I'm sure we will be expounding on very, very soon. So thank you for that invitation to invite you back. So if there was one parting message that you could impart on everybody that's going to watch this, Mr. Moore, when it comes to survivability only, because I got to keep you in a box here, otherwise we'll get into every other subject. What would you help them with? What would you leave them with?
Well, I would say that there's so much going around in this whole swirl of survivability, but you'll get a really good handle on it if you read through chapter 24 on the requirements for when you need survivability, and then read chapter 12, and then Article 760. That in itself will help guide you to keep out of most of the trouble. The rest of it will be common sense. The rest of it's going to be questioning the supplier that you're buying this stuff from, I've already heard this from some of the manufacturers. They go in and they say, you need to use this raceway. And the contractor says, no, but I always use XYZ raceway. Oh, okay, well then I'll just sell you the wire. Well, Mr. Contractor, I'm going to nail you to the wall when there's a fire and something doesn't work because you were supposed to use the XYZ raceway. So be very careful about how you handle this subject, because there's so many nuances involved that it's a big trap, if you will.
And I think that's great insight into the standards that people should be looking into. So make sure that you go pick up copies of 72 and the National Electrical Code of whatever project permit cycle you're on. So make sure you reference that and look at the state and find out what they're enforcing, and then pick up the phone and contact your local fire marshal who's going to be doing the inspection, and ask questions and say, listen, I've heard this great conversation about survivability. I know all about chapter 24 and chapter 12, and I'm going to approach the installation. Here's what the manufacturer recommends that I install. Can you please bless this so that I can go ahead and install my cabling system? And then you're good to go and you have nothing to worry about. But maybe you didn't know that, and that's the point of these conversations, is to elicit the information that can put you on the right path so that you can be successful, and Mr. Moore can continue to spread the great word about survivability and his amazing work and tenure in this industry. Sir, thank you for your service, for serving our country so well, both in the military. Thank you to your father for serving in the military. But overall, thank you for your tenure in this industry to keep so many people safe for all of the years that you've done what you've done. I hope that I can pick up that torch, and not that you're leaving it anytime soon, but I want to pick up that torch and continue to inspire others about fire protection and just help the industry to move forward and be change agents.
We need more people like you with the passion to do that. So I appreciate it.
That's awesome. Yeah, thank you so much. I appreciate your time, Mr. Moore. Thank you so much, and we'll be seeing you again soon about intelligibility.
All right, my pleasure, Joe.
All right, thank you very much. Take care.
Bye-bye.